JDWP messages follow a simple structure. Focusing on communications channel. The communications channel is the link between the front end and back ends of the debugger. It can be thought of as consisting of two mechanisms. One, a connector. A connector is a JDI object that is the means by which a connection is established between the front and back ends. JPDA defines three types of connectors. Listening connectors, the front end listens for an incoming connection from back end. Attaching connectors, the front end attaches to an already running backend. Launching connectors, the front end actually launches the Java process that will run the debugging code and the backend. To a transport. A transport is the underlying mechanism used to move bits between the front end and the back end. The transport mechanism is used. The transport mechanism used is unspecified. Possible mechanisms include sockets, serial lines, and shared memory. However, the format and semantics of the serialized bit stream flowing over the channel is specified by the Java Debug Wire protocol JDWP. Here you can see JDWP messages follow a simple structure. JDWP defines messages involved in communications between the debugger and debuggee. The JDWP is packet based and is not stateful. There are two basic packet types: command packets and reply packets. Command packets may be sent by either the debugger or the target VM. They are used by the debugger to request information from the target VM or to control program execution. Command packets are sent by the target VM to notify the debugger of some event in the target VM, such as a breakpoint or exception. A reply packet is sent only in response to a command packet and always provides information, success or failure of the command. Reply packets may also carry data requested in the command. For example, the value of the field or variable. Currently, events sent from the target VM do not require a response packet from the debugger. JDWP is asynchronous. Multiple command packets may be sent from the first reply packet is received. Command and reply packet headers are equal in size. This is to make transport easier to implement and abstract. The layout of each packet looks like this: command packet, header, length 4 bytes, ID 4 bytes, flags 1 byte, command set 1 byte, command 1 byte. Data is a variable length. Reply packet, header, length 4 byte, ID 4 byte, flag 1 byte, error code 2 bytes. Data variable length. All fields and data sent via JDWP should be in big endian format. The first three fields are identical in both packet types. Shared header fields here. Length. The length field is the size in bytes of the entire packet, including the length field. The header size is 11 bytes. So a packet with no data would send this field to 11. ID. The ID field is used to uniquely identify each packet command reply pair. A reply packet has the same ID as the command packet to which it replies. This allows asynchronous commands and replies to be matched. The ID field must be unique among all outstanding commands sent from one source. Outstanding commands originating from the debugger may use the same ID as outstanding command originating from the target VM. Other than that, there are no requirement on the allocation of IDs. A simple monotonic counter should be adequate for most implementation. It will allow 2 to the power 32 unique outstanding packets and is the simplest implementation alternative. Flags are used to alter how any command is queued and processed, and to tag command packets that originate from the target VM. There is currently one flag bits defined. Future versions of the protocol may define additional flags. 0x80, a reply packet. The reply bit, when set, indicates that packet is a reply. Command packet header fields here, command set and command. Command set, this field is useful as a means for grouping commands in a meaningful way. The sun-defined command sets are used to group commands by the interfaces they support in the JDI. For example, all commands that supports the JDI virtual machine interface are grouped in a virtual machine command set. The command set space is roughly divided as follows: 0 to 63 sets of commands sent to the target VM, 64 to 127 sets of commands sent to the debugger, 128 to 256 vendor defined commands and extensions. Command, this field identifies a particular command in a command set. This field, together with the command set field, is used to indicate how the command packet should be processed. more succinctly, they tell the receiver what to do. Reply packet header field error code. This field is used to indicate if the command packet that is being replied to was successfully processed. A value of 0 indicates success. A non-zero value indicates an error. The error code returned may be specific to each command set command, but it is often mapped to a JVM TI error code. Data. The data field is unique to each command set command. It is also different between command and reply packet pairs. For example, a command packet in a command packet that requests a field value will contain references to the object and fields IDs for the desired value in its data field. The reply packet's data field will contain the value of the field. Here you can see the request packet. Request header and data are in request packet. Length, ID, flags, set command set and command are in header. Here you can see the reply packet. Header and data are in reply packet. Length, ID, flags and error code are in header. As an example, we can consider now this is the end of my presentation. Thank you very much for watching it.